जय श्री राम एवरीवन। तो आज हम आ चुके हैं अपने डे 6 पे। आज हम पढ़ेंगे थोड़ा थोड़ा। कल हमने वीक 3 कंप्लीट कर लिया था अपने कोर्स के अंदर। तो आज हम स्टार्ट करने वाले हैं लिस्ट से। ठीक है। लिस्ट के अंदर हम क्या पढ़ेंगे, मतलब लिस्ट के अलावा और क्या क्या पढ़ेंगे। डिफरेंट डिफरेंट प्रॉब्लम्स है। बर्थडे पैराडॉक्स हुआ, और मैट्रिक्स एडिशन हुआ, डॉट प्रोडक्ट हुआ। ठीक है। ये सब सारी चीज़ें करेंगे। ऐसे मतलब अगर आप पाइथन के अंदर अगर आपको बेसिक्स वगैरह कुछ भी सीखना है, नॉर्मली मतलब स्टार्ट करो तो स्ट्रिंग और लिस्ट को पकड़ के बैठ जाओ। इसकी प्रॉब्लम सॉल्व करो। ठीक है। इनकी प्रॉब्लम सॉल्व करने से मतलब ग्रिप अच्छी बनती है, क्योंकि ये आपको इंडेक्सिंग सिखाते हैं कि लिस्ट के अंदर भी इंडेक्स होता है। ठीक है। अभी बताऊंगा मैं लिस्ट क्या होता है। मतलब मैं नहीं बताऊंगा, टीचर बताएंगे, हम तो पढ़ रहे हैं भाई। ठीक है। मेरा कोई कंटेंट नहीं है। मेरा तो बस कुछ भी नहीं है भाई। ठीक है। मेरी तो बस जस्ट 0.0001% नॉलेज है। वो मैं बीच बीच में थोड़ा सा बता देता हूँ, अदरवाइज मैं क्वेश्चन सोल्व करता हूँ जो कि नॉर्मल क्वेश्चन है। तो बस, तो हम यहाँ पे ऑलरेडी कर ही रहे हैं। ठीक है। तो चलो शुरू करते हैं आज का। ठीक है। लेट मी शेयर माय स्क्रीन। डन। सिस्टम ऑडियो, यस वी हैव। ओके। चलो जी। तो ये रहा हमारा इंट्रोडक्शन ऑफ वीक 4। ठीक है। कल हमने वीक 3 तक तो कर ही लिया था। कल हमने क्या क्या किया था, ये सारा कुछ किया था। वाइल टू कंप्यूट फैक्टोरियल, फिर फॉर लूप भी किया था, नेस्टेड फॉर लूप भी किया था, सब कुछ किया था। आपको वीडियो मिल जाएगी वो। मैं जो भी लाइव स्ट्रीम वाली वीडियो अभी उसको हटा नहीं रहा हूँ, ताकि सब लोग देख सकें। ठीक है। चलो इंट्रोडक्शन से स्टार्ट करते हैं।
So we'll be changing our gears and we'll be looking at some practice programs this week. So mostly we'll not be teaching anything new in Python, but we'll be making you get familiarized with the programming environment in general, in making you write some codes and making you get used to writing long codes. Okay, so what we'll be doing is we have picked some practice programs which we'll be using time and again in our forthcoming weeks too. So we are going to introduce you people to those programs this week, and some 5 to 6 questions we'll ask, write corresponding programs for it, and then the same code will be revisited in the forthcoming weeks, and we'll show you how you can better these codes as you learn more and more of Python. So to briefly state, we'll be discussing the birthday paradox. I'm sure you remember that from your computational thinking course. Some searching in a list, which again is going to be a very, very naive and straightforward way of searching. Sorting, the very, very obvious way, and some matrix operations. You see, your course involves good deal of understanding of matrices, and here we give an introduction to how to meddle with a matrix using Python. In fact, we are not going to go into the details of it, but we'll be discussing how you can find the sum or product of two matrices. And finally, here's a tip. The reason why we are dedicating this entire week for coding is to ensure that you get used to coding, right? Some of you are ahead, some of you are sort of behind, but don't worry. In this week, we will try to push all of you onto the same line, meaning people who are not very comfortable with coding will get comfortable, but you may want to follow this tip. The tip is code the same program multiple times. We have been saying this again and again. We would like to exert more on this very line, that you may want to write a piece of code by watching how we code, and then delete it, and then redo it independently. Okay? Do it multiple times and until you feel comfortable. All right? So good luck coding. Let's start off with some programming right now.
ठीक है। तो भाई वेलकम। ठीक है। चलो जी, करते हैं शुरू।
So if you remember, we did talk about lists. L is equal to, let's say 1, 7, 4, 2, 100, and close the big bracket, and this becomes a list. When I print this, it shows the values in this list, right? So from now on,
सबसे पहले बता देता हूँ मैं लिस्ट क्या होता है। वेट अ सेकंड, मेरे को VS कोड खोलने दो। ये रहा। हाँ। तो लिस्ट कुछ भी नहीं है भाई, एलिमेंट स्टोर करने का एक जरिया है। ठीक है। अब जैसे कि कुछ मान लो हमने कुछ भी वेरिएबल डिक्लेयर किया। वेरिएबल पहले हम क्या डिक्लेयर करते थे, एन डिक्लेयर करते थे। एन इज एन पे असाइन कर रहे हैं हम 4। ठीक है। 4 इज असाइन टू एन। बट नाउ आई वांट कि मल्टीपल वैल्यूज है हमारे पास में, जैसे कि 5, 6, 7, 8, 9, 10। तो अब सबके लिए मतलब अलग अलग थोड़ी ना करेंगे, ठीक है। ऐसे बहुत सारे वेरिएबल हो जाएंगे और उनको याद रखना भी थोड़ा मुश्किल हो जाता है, ठीक है। और भी बहुत सारे डिफरेंट यूज केसेस होते हैं जिसके लिए फिर हमें क्या चाहिए, हमें चाहिए एक ऐसा वेरिएबल जिसके अंदर सारी की सारी वैल्यू स्टोर हो जाए और हम उनका यूज भी अच्छे से कर सकें। तो फिर उसके लिए क्या करते हैं, उसके लिए हम लिस्ट बनाते हैं। मतलब और भी बहुत सारी चीजें हैं, लिस्ट है, टपल है, डिक्शनरी है, ठीक है। बट सबसे पहले तो हम लिस्ट बनाते हैं। लिस्ट का क्या सीन रहेगा, लिस्ट वन लेट्स सपोज, जो कि हमारी फर्स्ट लिस्ट है, एंड फिर इसको डिनोट करते हैं इससे क्लोज ब्रैकेट से, ठीक है। तो अब इसके अंदर ये सारे के सारे जो भी हमारी वैल्यूज थी वो सारी की सारी लिस्ट वन में है, ठीक है। इसको प्रिंट भी कर सकते हैं, प्रिंट लिस्ट वन, ओके। तो ये आ गई हमारी लिस्ट प्रिंट। अब तुम आए, तुमने कहा नहीं सर ये तो आपने सब कुछ दे दिया, हमें चाहिए सिर्फ सेवन, ठीक है। अब सेवन को कैसे लेंगे, तो उसके लिए सेम इंडेक्सिंग का यूज करेंगे। इंडेक्सिंग का यूज करने के लिए जीरो से स्टार्ट होगा ये, ठीक है। यहाँ पे आएगा जीरो, देन वन, देन टू, देन थ्री, देन फोर, फाइव, ठीक है। तो अभी अगर मैं लिखता हूँ कि लिस्ट वन जो है उसके अंदर मेरे को चाहिए भाई साहब, सॉरी एकदम एज पे रखा हुआ है, सॉरी सॉरी, ठीक है। हाँ, तो अभी क्या है भाई, एक बार तो जान हलक में आई थी, चार्जर ने बचा लिया, ठीक है। तो अभी लिस्ट वन में क्या सीन रहेगा, मेरे को कोई भी वैल्यू, लेट्स सपोज मेरे को सेवन चाहिए, तो फिर सेवन के लिए कहाँ से क्या लिखेंगे, दो लिखेंगे, एंड प्रिंट करने की जरूरत ही नहीं है, सीधा डायरेक्ट सेवन आ गया, ठीक है। तो ऐसे अप्रोच करते हैं वैल्यूज को, ठीक है। और भी बहुत सारे फंक्शंस होते हैं जैसे कि लिस्ट वन, और फिर अगर मैं इसको सम कर दूं, सम आएगा क्या, नहीं आएगा, तो फिर एस यू वन, हाँ इसमें आता है, ठीक है। तो अब इस पूरे का सम निकाल दिया, ठीक है। हमें एक एक वेरिएबल को ऐसे ऐड करना नहीं पड़ा एंड ऑल, वो भी सीन रह गया। और अगर मेरे को इसके ऊपर फॉर लूप चलाना है तो वो भी इजीली चला सकते हैं, कैसे, फॉर आई इन लिस्ट वन, ठीक है। तो मैं इसको थोड़ा सा बड़ा कर देता हूँ, आई होप अभी विजिबल होगा, ठीक है। तो फॉर आई इन लिस्ट वन, और अभी अगर मैं प्रिंट करता हूँ आई को, तो ये एक एक वैल्यू को प्रिंट करेगा, ठीक है। चलो एक काम करते हैं, यहाँ पे एंड लगा देते हैं, एंड इज इक्वल्स टू ये दो सर कुछ भी नहीं, ठीक है। चलो इसको रन करते हैं, फाइव सिक्स सेवन एट नाइन टेन, अगर हम यहाँ पे स्पेस डाल देते हैं तो फिर स्पेस के साथ में आ गया, ठीक है। तो ये सीन रहेगा लिस्ट के अंदर। अब देखते हैं कि वो क्या कह रहे हैं आगे। लिस्ट का तुम्हें आइडिया मैंने मेन मेन बता दिया कि लिस्ट क्यों यूज करते हैं एंड लिस्ट होता क्या है, ठीक है।
Onwards, we'll be using the IPython shell. This is called the interactive Python shell on the right, as you know. And as I expect, I believe you're familiar with this interactive Python shell on the right. On the left will be the code that we'll be writing. Many a times we may want to execute a few commands by typing them here, right? So just now I said L equals so and so, it created a list. Then I said print L, it did print the entire list, right? I can, if I want to add some value to it, by add I mean include a value to this, I can say L append 1024. And what will happen? Let's see. You get 1024 here, right? A few more points to note. When I say L append, once again, 2, it does include 2 twice.
हाँ, तो अपेंड का क्या सीन रहेगा, अपेंड क्या करता है, मतलब हमने ये लिस्ट बना दी, ठीक है। इसके अंदर सारे के सारे वैल्यूज हमारे स्टोर हो रहे हैं, लेकिन हम चाहते हैं कि इसके अंदर एक और वैल्यू ऐड करना है हमें, ठीक है। तो वो ऐड कैसे करेंगे, उसके लिए हम यूज करते हैं अपेंड का, ठीक है। तो अभी लेट्स सपोज कोई भी एक लिस्ट है मेरे पास, लिस्ट वन, उसके अंदर मेरे को करना है, ऐड करना है, तो उसके लिए मैं यूज करूंगा अपेंड। अब यहाँ पे कोई भी वैल्यू दे दूंगा, ठीक है। थ्री दे दिया लेट्स सपोज, तो फिर वो अपेंड कर दिया उसने। अब लिस्ट वन को अगर देखेंगे तो थ्री आ गया, ठीक है। असाइन करने की जरूरत नहीं पड़ेगी, मतलब ऐसा नहीं है कि लाइक अपेंड भी करना पड़ेगा फिर लिस्ट वन के अंदर दोबारा से असाइन करना पड़ेगा, नहीं इसकी जरूरत नहीं है, बस आप अपेंड करो एंड फिर प्रिंट करो, ठीक है। तो ये सीन रहेगा। एंड तो बस फिर एक तो ये अपेंड हो गया, और भी बहुत सारे फंक्शंस होते हैं यार। अगर तुम पाइथन के अंदर घुसोगे तुम्हें बहुत सारे फंक्शंस मिलेंगे। धीरे धीरे करके सबको करना, एक साथ में नहीं करना। एक साथ में करोगे थोड़े से वो हो जाए पूरे। मतलब सीधी सी बात है, जो काम आता है उनको याद रखो। अपेंड हुआ, ठीक है। सम हुआ जो मैंने अभी मतलब दिखाया था। और इसके अलावा ऐड आइटम भी शायद होता है। बहुत सारे होते हैं यार। रिमूव भी होता है, ठीक है, वो रिमूव करने के लिए होता है।
You see, we all have learned in our this. In a it's understood. Functions. It is only easy to guess. What will L be now? L will have everything that it had initially with the number 1 removed. As you can see, 1 is removed, it starts from sum, right? So now, what is your guess? What if I remove, let's say 100? It removes 100, right? There's no questions there, right? It's very obvious. But what if I say remove 2? The number 2 is repeated twice here. So possibility 1 is it will remove the first occurrence of 2, or maybe the second occurrence of 2, or maybe it will remove both, right? So let's see what it does. Let's print L, and you see it has removed the first occurrence of 2. Just in case I typed it once again, it removes the other occurrence of 2. I hope this is clear. This much of lists you need to know. All right, let's get started with some more ideas with lists. Let me clear the shell. What I'm now going to tell you is probably one of the most important ideas in data sciences. And what is that? That's a matrix. And how do you represent matrices? There are actually very sophisticated ways in which you can represent a matrix in Python. In fact, there's a library function called the NumPy, numerical Python. We'll not get in there. I'll now tell you a very naive way of representing a matrix. So as you can see, I created a list L, and I appended 1 to it, I appended 2 to it, I appended 3 to it. Okay, so sometimes I may not want to type the entire command. A simple up arrow will repeat the previous command. Okay, another up arrow will repeat the previous to previous command, and so on, right? Okay, so now when I print L, it shows me 1, 2, and 3, exactly what I have appended here, as you can see. All right, so as I've been telling you people, a computer is indeed a very dumb machine. It cannot do anything that you don't tell it to do. Okay, fine. So now, what is your guess? What if I create another array X, and then I append L to X? You see, that's strange. Let me try doing that. Oh, well, it accepted. There was no error. What does it even mean? I'm creating an array X, and I'm appending another array L to X. How does it look like? Let me print X and see it. You see, it is an array and it contains another array. Let me create, just for example, let's say M equals 10, 20, 30. And let me take X just the way I appended L into X. Let me append M into X. Now when I say print X, it prints 1, 2, 3, 10, 20, 30. So it is a list within a list. There's a very popular idiom in English called wheels within wheels. So it is idea within an idea. You'd have heard this, right? So a problem within a problem, right? So you see, this is a list within a list. Okay. So as you all know, there are many living, many microorganisms inside our body, right? So a living organism within a living organism, right? Something like that, right? So anyway, you'll get used to it. In fact, there's no limit here. You can have a list of 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 a list. Okay, you can go to infinity like that. So just to complicate, to make your life tough. Why should we not teach you complicated stuff? Why should it always be easy? Let me complicate it by typing another list. Let's say T. I'll call it a list, and I'll append X to it, and I'll print T. You see what's happening? Now here is a list containing a list containing 2 lists, and I'll append another thing to T, which is 100, 101, 102, another list. If I print T, something else is coming, right? A list. First, you see, this is a list 10, 20, 30. You probably are wondering why is he wasting time. So this is important. Don't worry. With time, you realize what I'm doing. In fact, it will come naturally to you, the idea of list of lists. Okay. So then this is another list 1, 2, 3, another list 10, 20, 30, and these 2 things put together is another list, as you can see. Right? This much, these 2 things put together is this list. Let me start carefully and then say, this list. This is an element of the bigger list. And the bigger list has the second element as this. So it will be clear when I say T of 0. What do you expect T of 0 to be? If I were to print T, in fact, you can simply say T of 0 also, it will print, but I'll not do that. So print T of 0 will give you the first element of the list T. Alright? T of 1 will give me the second element of the list T. So let's now create a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. So how do I do that? A matrix M, let me say capital M is equal to so much, and I'll append first, let's say 1, 2, 3 to it. I'm sorry, you may not be able to see this. Okay, so you have M append 1, 2, 3, and then I say M append 4, 5, 6, right? And then I'll say M append 7, 8, and 9. M append 7, 8, 9. So I think it's clear. So let me press many return keys so that it comes to the center and you can see it. M append 1, 2, 3, M append 4, 5, 6, M append 7, 8, 9. I'll frequently keep clearing kernel so that it refreshes. In fact, I can also use the clear screen, but I prefer doing it like this. Okay, so I would have lost all the content that I had typed, so I'll type it once again. M is a list. I'll append 1, 2, 3 to it. I will again append 9, right? And then I'll print M, capital M, and I get 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is how I'm going to treat a matrix. By treating a matrix, I mean this is how I'm going to store a matrix using lists. So you know M of 0 will be so much, and M of 0 is a list containing 1, 2, 3, and in that list I can see the first element, which is 1. In that list I can see the second element, which is M of 0, 1. You see,
लिस्ट के अंदर हमने एक चीज़ पढ़ी थी, मतलब बचपन में जब हम 11th में थे शायद, या फिर 9th 10th में, यार याद नहीं है मेरे को, ठीक है। उसके अंदर ये हमने पढ़ा था कि ये मैट्रिक्स होता है 1 2 3, ठीक है। मतलब वो पूरा बड़ा वाला यहाँ पे ब्रैकेट होता है, ठीक है। अभी के लिए हम छोटे, मतलब इसमें बड़ा मैं लिख नहीं सकता। और फिर यहाँ पे होता था लेट्स सपोज 4 5 6, एंड फिर यहाँ पे होगा 7 8 9। तो ऐसा वो होता था, यहाँ पे पूरा बड़ा ये, एंड फिर यहाँ पे ये, और फिर इसको हम बोलते थे 1 1, ठीक है। फर्स्ट रो फर्स्ट कॉलम, देन फर्स्ट रो सेकंड कॉलम, देन फर्स्ट रो थर्ड कॉलम। तो ये कितना हो गया? ये तो हो गया 1 1, ये होगा 1 2, ये होगा 1 3, फिर ये होगा 2 1, ठीक है। और ये होगा 2 2, और ये होगा 2 3, फिर ये होगा 3 1, ये होगा 3 2, और ये होगा 3 3, ठीक है। तो ये लोकेशन होती थी, और जैसे ही वो लोकेशन लिखते थे, मतलब लेट्स सपोज इस मैट्रिक्स का नाम है ए, तो फिर अब जैसे ही हम, मतलब सॉरी, इसको नीचे लेकर जाते हैं, ए के पाँव के नीचे, यहाँ पे नीचे लिखते थे 1 3, ठीक है। तो 1 3 वाली वैल्यू आ जाती थी, ठीक है। तो हमने ये काफ़ी कुछ किया है, लेकिन अब यहाँ पे क्या होता है मैट्रिक्स के अंदर, सॉरी लिस्ट के अंदर, 1 तो यहाँ पे होता ही नहीं है। स्टार्टिंग कहाँ से होती है? स्टार्टिंग होती है हमारी 0 से। तो फिर ये होगा 0, एंड ये भी होगा 0, ठीक है। ये होगा 0, जबकि 2 होता है 1, क्योंकि वो एक एक बैक खिसक गया ना सब कुछ। 0 यहाँ पे, 2 यहाँ पे, ये हो गया 1, और ये हो गया 0, ये होगा 1, ये भी 1, ये 1, और ये 2 2 2 1 2 0 एंड 2, ठीक है। तो ये सीन रहेगा। अब इसको थोड़ा सा सही लिख देते हैं, हाँ ठीक है, ठीक है। तो अब ये सीन रहेगा, एंड अगर आप A00 को कॉल करोगे, फिर A00 क्या है? ये हुआ 1, A00, ठीक है। ये तो रिप्रेजेंट कर रहा है रो को, ये रिप्रेजेंट कर रहा है कॉलम को, तो इसलिए 1 आ रहा है, ओके। फिर अगर हम प्रिंट करते हैं कि कॉलम तो, सॉरी रो तो ले लो आप दूसरी, तो दूसरी रो कौन सी होगी? ये तो फर्स्ट रो है, ये सेकंड रो है। सेकंड रो के अंदर आपको थर्ड कॉलम चाहिए, तो फर्स्ट सेकंड थर्ड 6 आएगा, ठीक है। तो ऐसे करेंगे।
in matrices we would write a subscript ij, aij, a11, a12, a13, etc. So similarly here we say m of 0 2 is equal to so much, so on and so forth. So what all did we learn just now? So just to end this, I'll also show you what is in the diagonal. What will be in the diagonal? M of 0 0 will be 1. So please note, you can say print or simply write the variable, it will still display. Okay. What is m of 1 1? This is called the diagonal elements in the matrix. 1 and 5. M of 2 2 is 9. I'm not going in detail here because I assume you have undergone the computational thinking course and you are used to this.
2 and 2, ठीक है। तो ये 2 and 2 लास्ट वाला था, ओके। तो ये लास्ट वाला क्या है? 9 है, तो 9 ही आया, ओके। तो ये सीन रहेगा। आई होप इट हेल्प्ड।
One dimensional and two dimensional thinking. Okay, so we now, while a list is one dimensional, what I'm doing is, by making a list within a list, I'm creating what is called two-dimensional data. Right? So the word two-dimensional data individually makes sense, but put together, what does it mean? You will get to know of it in some time. All right? So that's about lists. You understand something about lists right now. The best way to understand lists is to go ahead and write a piece of code about it. From now onwards, we'll be discussing almost in every single code we'll be using list. At least I have used it in the code that I have done in the recent past. So I believe even you'll be using it. So at least in this week's discussion, we'll be using good amount of lists. So it's good to get used to what are lists. So go ahead, open your terminal, start.
हाँ भाई, लिस्ट काम किया एक्चुअली, काफ़ी ज़्यादा काम किया। लिस्ट हुआ और स्ट्रिंग हुआ, ये दोनों बहुत काम किया।
Taught you a while ago. Remember the import math as well that we taught you? The import random is going to be a very useful tool. I'm going to use that now. And then if I say print random, you know what that does? Execute this, it shows me a random number between 0 and 1, as you can see in the terminal, right? So what I will now do is, instead of printing a random number, I'll delete this, I'll initiate a list L, and I'll append a random number, right? And then now if I print L, what will it do? It will create a list, and it appends a random number between 0 and 1, and then assuming I keep doing this, and then again print L, it will keep, it displays L with one number included, and then with the same L, I append another random number, and here's another random number, and that again gets displayed here. So spend a minute, pause the video, and try to see what am I typing here, and what is the output here. Alright, so what I'll now do is, I will not type this twice, I'll type this maybe 10 times. So how do I do that? For I in range 10.
ये भाई मैट्रिक्स ही बनाएगा, तो पहले हम ही बना लेते हैं, ठीक है? अदरवाइज मतलब फिर वो मतलब चीटिंग जैसा हो जाएगा फिर, तो बेटर है कि हम पहले बनाएं। तो सबसे पहले तो इंपोर्ट कर लेते हैं, इंपोर्ट रैंडम, ठीक है? एंड फिर हम फॉर आई इन रेंज 10, ओके? फिर हम करेंगे कोई भी नंबर एक बार के ले लेते हैं n, एंड फिर यहाँ पे रैंडम डॉट रैंडम, पहली तो लाइब्रेरी है, दूसरा इसका फीचर हुआ, एंड वो हमने कॉल कर लिया, ओके? एंड फिर हम कोई भी लिस्ट बनाते हैं, लेट्स सपोज लिस्ट 2 जो कि खाली है, तो हम उसको करेंगे अपेंड लिस्ट 2 डॉट अपेंड, अपेंड में क्या है n, ओके? तो ये बार बार चलता रहेगा 0 to 9, ओके? 0 to 9 चलेगा ये, 1 2 3, लेकिन हमें 9 तक चलाना है इसको, वेट 9 तक चलाएगा तो फिर 0 to 8 चलेगा, हाँ सही है, 0 1 2 3 4 5 6 7 8, हाँ ठीक। तो अभी हमें क्या चाहिए, अभी हमें बनाना क्या है, हमें बनाना 1 2 1 2 3 कोमा यहाँ पे ये, फिर 4 5 6, फिर वापस से कॉमा, फिर ये, फिर 7 8 9, हमें ये बनाना है, ओके? तो ये तो हुई हमारी लिस्ट 2, लेकिन अगर हम इसको n को भी एक लिस्ट बना दें, n भी क्या है, लिस्ट है, और इसको बना देते हैं j, लेट्स सपोज, तो फिर आप उसके अंदर n डॉट अपेंड j, तो ये तो होगी हमारी एक्सटर्नल वाला जो येलो कलर का है, फिर येलो कलर का तो येलो ही लिख देता हूँ यार इसको, येलो, एंड ये है हमारा पर्पल कलर का, तो p, तो अभी यहाँ पे आएगा p, एंड यहाँ पे आएगा y, ठीक है? और इसको फिर p है यहाँ पे, तो फिर यहाँ पे भी क्या आना चाहिए, p आना चाहिए, ठीक है? ओके, एक तो सीन हुआ ये, ठीक है? फिर हमें क्या करना है, हमें काउंट करना है, एक फ्लैग बनाएंगे, फ्लैग को लिखेंगे यहाँ पे COUNT, काउंट इज इक्वल टू 0, यहाँ पे डालेंगे इफ कंडीशन, इफ काउंट इज लेस देन 0 पे चलेगा, 1 पे चलेगा, 2 पे चलेगा, 3 पे नहीं चलना चाहिए, तो फिर ये लगाया ये, एंड अभी क्या करना है, काउंट को इंक्रीज करना है, काउंट प्लस इक्वल्स टू 1, ओके? तो ये p के अंदर चली जाती रहेगी वैल्यू, ठीक है? और उसके बाद में जैसे ही इससे बाहर निकलेगा ये, तो फिर काउंट की वैल्यू 0 हो जानी चाहिए। नहीं, इससे बाहर नहीं, इससे बाहर COUNT इक्वल्स टू 0। ठीक है, काउंट की वैल्यू 0 हुई। काउंट की वैल्यू 0 होते ही वापस यहाँ पे जाएगा, और पी भी क्या हो जाना चाहिए, खाली हो जाना चाहिए। बट यार ये सही नहीं है अभी भी। 3 बार वो चलना चाहिए, 3 बार ये चलना चाहिए, तो 9 हो जाएगा। तो फिर मैं काम करता हूँ, यहाँ पे भी 3 लगाता हूँ। ठीक है, यहाँ पे भी एक और फॉर लूप लगाता हूँ। फॉर इन लेट्स सपोज क्या, पी नहीं, पी नहीं, पी यूज कर चुके हैं, एस कर देते हैं। एस इन रेंज, यहाँ पे भी आएगा 3। इसको डालते हैं अंदर अंदर अंदर। हाँ, अब ठीक है, अब चलना चाहिए। लास्ट में जब प्रिंट करेंगे वाई, प्रिंट वाई, तब ये आना चाहिए। सिंटैक्स एरर, ओके। तो ये हुआ हमारा पहला वाला मैट्रिक्स। ठीक है, फिर ये हुआ दूसरा वाला मैट्रिक्स, और फिर ये हुआ तीसरा वाला मैट्रिक्स। अरे नाइस, क्रिएट कर दिया हमने। ठीक है, गुड गुड गुड, सही है यार। चलो अब कंटिन्यू करते हैं इसको।
Yes, perfect. I say L append random random and then print L. This will give me, okay, you see what's happening. I'm printing the list every time. So it's displaying every time a random number gets appended. So if I remove the tab, it means this comes outside the for loop. And as you would expect, what should be the output here? Let's execute it. It will show the list only once because you're displaying it only once. You have removed that from the for loop. All right, to avoid confusion, maybe it will also help if I put another enter here, empty line here, right? So I do have these 10 random numbers here. As you know, we also have what is called the rand int. And I can say 1, 10. Let's see what this does. It simply appends a random number between 1 to 10 here into this list. So the fun part about computers is that you can simply increase these numbers and boom, it becomes 10, became 100, right? I'm appending 100 numbers here. So please note, it started off with 1, but it starts with 9 here. That's because it's a random number that you are appending and you're executing the program afresh. That's why it doesn't append to this list, but starts a new list every time we execute this program. So what I'll do is I'll keep this in the middle of the screen so that you can see it. Better even clear the screen. Okay, as you can see now, instead of 100, if I do, let's say 10,000, it will indeed show 10,000 entries. Boom, look at that. It was really, really fast. You can add many numbers and you can observe that it's a lot faster than what you would expect it to be. So I'm now appending 1 million numbers. Man, it takes time, but it does get back, as you can see. So many numbers, and you can, let me just reduce this by, I'll keep it 100,000, and then, which is like 1 lakh, and then include random numbers from 1 to 100, or maybe 1 to 1000. I'm executing. You see numbers from 1 to 1000 randomly put here. Why would I do something like this? Okay, so we are heading towards a topic that you studied in computational thinking, the birthday paradox. Okay, before that, we would like to see how we can model it using Python. So what exactly happened in birthday paradox? Let me try changing these values, and you will probably quickly say, Eureka, you found that out, in the sense that you understand what I'm trying to say. What is this? Let me clear the screen this side. Okay, what is this? I'm saying create a list L. So as I've been telling, it's important to type comments. Create an empty list, or rather initialize an empty list. Okay? What I do is append random numbers between 1 to 365. How many should you append? Append 30 of them. Right? Let's see, this is what is happening. Execute it, and you see this is precisely what's happening. You have 30 random numbers between 1 to 365. As you would have guessed, 1 to 365 stands for day in a particular year. So if I'm born on January 1st, the number is 1. If I'm born on December 31st, the number is 365. All right. So when you pick 30 people and ask them for their birthday, their DDMM, day and month, not the YY, if you remember, you don't look at the year of birth in the birthday paradox. If you're wondering what we're talking, you may have to revise your computational thinking course, this part where the instructor discusses the birthday paradox. In fact, it's a very interesting discussion as I watched, and there's a surprise factor there that even if you take a very few number of people, you will get 2 people with the same birthday, right? So I have taken 30 people here, and I'm going to execute it. I've got these numbers, so you got to tell me if there's any repetition here, right? So I do not see a repetition, or maybe I'm bad at seeing if there's a repetition or not. There's a nice way to do this. This was your L, right? Yeah, so if you're wondering what I'm doing, whatever you have written here, those variables can be called here too. L had these numbers, I've included L. There is something called sort function built within the list. So when you say L.sort, it simply sorts it. Okay, you can print L. Now it's easy to see if there's repetition or not. Let me check. 154, 167, there's a repetition. And what does it say? It gives a proof that birthday paradox indeed seems to be true. Why? As you can see, when you pick 30 random numbers from 1 to 365, this amounts to, this translates to you going on the road and stopping some 30 people and asking them for their birthday. Of course, you shouldn't do that. Nobody will tell you their birthday, especially on the road. But if you randomly pick some 30 people, let's say from your friends or in a classroom, and ask them for their birthday, you will observe that 2 people will have the same birthday. Right? So you must be wondering, is this always true? Not really. This may not really be true. I'll show you an example. Just a minute. So let me put L sort here itself so that it displays now a fresh bunch of 30 people. I see, is there a repetition? 86, 87, 91, 119, 143. There is no repetition here. Surprisingly, there's no repetition here, which means this is not always true if you take 30 people. Here and there it may fail. I'm repeating it once again. 32, 32. Bingo, there's a repetition here. I'll repeat once again, and let's see, there is no repetition. Not 29, 129 is a repetition here. Okay, only here there was no repetition, right? So, or did I skip seeing that? It's very difficult, right? So, 143, etc., etc. There are no repetitions here. Okay, so why should we do this manually? Why can't we write a piece of code that checks if there's a repetition or not? How do I go about it? So, it's pretty.
ओके, तो ये फाइंड आउट करना है अभी. चलो, ये चलो हमने एक्स्ट्रा में सीख लिया. ठीक है, नेस्टेड लूप का हो गया वो, तो चलो छोड़ो उसको. ठीक है, अभी हमें क्या करना है? हमें सबसे पहले तो रैंडम तो हमने इंपोर्ट कर ही दिया था. हमें एक लिस्ट बनानी है फॉर आई इन रेंज 30 लोगों की, एंड उन 30 लोगों में से सबसे पूछना है कि जो हमारी लिस्ट है उसको आप भर दो. क्या कह करके कि लिस्ट 3 डॉट अपेंड रैंडम डॉट randint and 1 2 3 65. ठीक है, फिर प्रिंट कर दो लिस्ट 3 को. तो ये हो गए हमारे 30 लोग. ओके, अब हमें क्या करना है? ये कह रहा था कि लिस्ट 3 को अगर हम कर देते हैं सॉर्ट, और फिर मतलब प्रिंट करते हैं इसको. अरे क्या सीन हो गया? एल डॉट सॉर्ट और फिर प्रिंट एल. तो ये सॉर्टेड अब 16 22 47 69 94 180 12. यार मेरे को तो एक पे ना दिख रहा है यहाँ पे. एक भी ना है यार. नहीं है. चलो कोई ना, नहीं है तो कोई तो क्या, वो लिस्ट तो है ना हमारे पास. अब क्या करना है? इसके अंदर कोई भी एक एलिमेंट पकड़ो एंड फिर उसको सबके साथ में कंपेयर करो कि है या नहीं है. अगर नहीं है तो फिर दूसरे को पकड़ो और फिर बाकी सारे एलिमेंट्स को देखो. फिर तीसरे को पकड़ो, फिर सारे एलिमेंट्स को देखो. तो ऐसा करना है वो ना. ठीक है, तो फॉर आई इन लिस्ट 3, तो ये पकड़ लिया हमने. 16 आ गया यहाँ पे. ठीक है, अब इसको देखना है इफ आई जो है वो है इन लिस्ट 3. वो तो है क्योंकि ये रहा 16. तो हमें इसको छोड़ करके आगे का देखना है. तो वो कैसे करेंगे? इसका तरीका है ये कि हम यहाँ पे लगाते हैं रेंज, ओके, फिर इसकी निकालते हैं लेंथ, ठीक है। इस लिस्ट की हमने लेंथ निकाली जो कि आएगी 30 के अराउंड, एंड फिर अब सबका इंडेक्स मिलेगा हमें 0 1 2 3, ठीक है। तो यहाँ पे क्या आएगा, अभी जो फर्स्ट आएगी उसमें आएगा 0, ठीक है। तो यहाँ पे आएगा 0। अब हमें ये करना है कि ये जो एलिमेंट है, तो यहाँ पे एलिमेंट लिखेंगे, वो क्या है, लिस्ट 3 आई, आई की जगह क्या आएगा 0, तो फिर ये क्या हो गया 16 हो गया, ओके। इफ आई इन, यहाँ पे लिखेंगे अब ये स्टेप तो होता है ऑलवेज 1, एंड डिफॉल्ट कर दो, स्टार्टिंग वैल्यू कर देते हैं i+1, ठीक है। एंड अगर ऐसा है तो फिर प्रिंट कर दो बिंगो बर्थडे पैराडॉक्स, ओके। लेकिन अगर ऐसा नहीं है, लेकिन फिर लास्ट वाले एलिमेंट में क्या होगा, जो लेट्स सपोज ये 30 आ गया, यहाँ पे आ गया 30, तो फिर ये कितना हुआ 328, तो फिर यहाँ पे 30+1 हो जाएगा जो कि इसमें है भी नहीं। तो फिर उसके लिए हम फिर से एक और कंडीशन लगा देते हैं, इफ i is less than कमांड सी कमांड पी, ठीक है। तो ये लगा दिया अब हमने, तभी इसके अंदर जाएगा जब ये 29 या 29 से कम है, तो ये चल जाएगा सारा का सारा। चलो अब इसको रन करते हैं, पर इसमें तो बर्थडे पैराडॉक्स है ही नहीं। एक काम करते हैं, एक फ्लैग बनाते हैं, ठीक है। फ्लैग को रखते हैं हम फॉल्स, ओके। एंड जैसे ही ये होता है तो हम यहाँ पे बिंगो को एक बार हटाते हैं, यहाँ पे डालेंगे फ्लैग इज इक्वल्स टू ट्रू, ओके। एंड यहाँ पे डालेंगे इफ फ्लैग इज इक्वल्स टू ट्रू डबल इक्वल्स टू, क्योंकि हमें कंपेयर करना है, एल्स प्रिंट आर्क नन, ठीक है। दोबारा से रन करते हैं इसको नीचे ले आते हैं यार, कमांड सी कमांड पी, ठीक है। अब ये दोबारा से करेगा बिंगो बर्थडे पैराडॉक्स, तो अब यहाँ पे क्या पैराडॉक्स है, वेट देखते हैं। लिस्ट 3 को पहले तो सॉर्ट करना पड़ेगा, एंड फिर आएगा, फिर लिस्ट 3 डॉट सॉर्ट एंड लिस्ट 3 बिंगो 1937 66 67 72 82 87 93 96 123 123 154 194 बूम। तो ये हो गया, तो इसलिए हमारा आ गया बिंगो बर्थडे पैराडॉक्स।
Pretty simple. What I'll do is I'll say while I is less than or equal to length of L minus 1. What does this stand for? Always length of L will tell you the length. Okay, so I mean, how many entries are there in L? I should take minus 1 because I need to go up to the 29th element. You see, length of L minus 1 will be 29. Please observe carefully. When I say L of 0, it gives me the first element of L, 36. Right? When I say L of 1, it gives me 66. L of 2 will give me 85, and so on. What is L of 28? Can you guess? L of 29. Go up to len of L minus 1. Okay, so what's the syntax? I say colon here, then go here. I don't like this error messages. So len of L minus 1, what equal to L of I plus repeats. Okay, else does it repeat? Okay, it matters for
ओके, तो इन्होंने ऑलरेडी सॉर्ट कर रखा है
need
ना,
to make some errors in my
इसलिए
code.
इसलिए ये लिख रहे हैं कि i इज इक्वल्स टू i+1। ठीक है, अगर ये सॉर्ट नहीं करते हैं तब प्रॉब्लम आएगी, क्योंकि तब तो मैच नहीं करेगा, शायद ही करेगा। ठीक है, क्योंकि ये सिर्फ एक आगे वाला देख रहे हैं।
Then you will realize what goes wrong here. So I should be doing this. You see what will happen if this happens. If L of it starts with 0, basically I should be equal to 0. I is 0. 0 is less than or equal to ln of L minus 1, which is true. It comes inside. Is L of 0 is the same as L of 1? So let me go ahead and then see that array here. So it will just let's use this as the array. L is this here. Okay, so let me print L so that it's clear to you. So L of 0 is 36. Is 36 equal to 66? No, it is not equal. So it doesn't get repeated. And it says doesn't repeat. No, that is not true. I want to go until the end and then say doesn't repeat. Okay, so I'll do a small trick. It may take some time for you to understand what this trick is. The trick is I'll say flag equals 0. Okay, which means denotes that you have not seen two elements which are equal, two consecutive elements that are equal, which means flag never becomes 1, which means your flag is 0. Then I say if flag is equal to 0 equals I plus 1, then of L is I, L of throws an error, right? Because L of I plus 1 becomes L of 30. L of 30 is not here at all. So you should not be comparing L of 29 with L of 30, which means you should not go till the last step. You must go to the second last step. So you should stop when I equals 28. And they should get 257,270. Boom, there is no repeat. Let me, you see, now you specify what you ask it to do. The moment it repeats, you're coming out. You're saying break, stop. I've seen repetition, right? When you're checking for 30 people, the moment you see two people the same birthday somewhere, you stop. Right? By the way, they don't come in this ascending order. We are sorting the list. That is why it is being displayed in ascending order. You see? All right. So the moment you see the repetition, you stop. You may not want to do that. Maybe you can modify this code a little. I'll leave that as a homework. It is pretty straightforward. We'll take another 20 minutes of our time. I'm not ready to spend that right now, but I want this as an exercise that you can take home and then try to figure out how to do it. So what you should do is you should show the repetition and you should also show all the repetitions. Okay? Which means
अगर हमें रिपीटेशन यहाँ पे शो करनी है कि कौन सा हुआ है, ठीक है, तो उस केस में करेंगे यहाँ पे बस ये तो प्रिंट करना। थ्री 2,147, 343 यहाँ पे है, 343 यहाँ पे है, और क्या बोल रहा है 147 बोल रहा है। 147 एक तो यहाँ पे है और एक यहाँ पे है, फिर बोल रहा है 54 एक तो ये हुआ, एक ये हुआ, ठीक है। बिंगो, इट्स अ बर्थडे पैराडॉक्स। चलो जी, ये भी हो गया।
means once it repeats, you should not break. You should come once again and then check whether it repeats or not. All right. Sometimes it may repeat twice or 4 times, 5 times. Okay. You should be able to see that. All right. There is no repetition. Repeats. Looks like every now and then it doesn't repeat. There is no repetition once again. Let's try executing this again and again. No repetition. Repeats occasionally. Not occasionally. Almost 1 in 2 times when you run this experiment. How many times have you run here on this page? No repetition. Repeats. Probability. It's happening with, let's say, probability half. Expect the phrase I run the experiment. It's repeat. 7th one, it says no repeat. Tired now. It is not always all right. In fact, 30. Oh God, what's happening? Repeats. There's no repetition. Repeats. There's no repetition.
चलो जी, अब चलते हैं नाइव सर्च इन अ लिस्ट। कुछ लोग नेव सर्च भी बोलते हैं, करते हैं उसको।
So we are going to go ahead and try to write a small code to search for an element in a big list. Firstly, let me tell you how to create a big list. All right. So how do we go about it? You can always type in a big list like this, right? 99, 6, 144, 86, and so on. That is the biggest list I could type in less than 10 seconds. But if you want to type a bigger list than this, there's a way to do it. So how do you do it? Say import random and then to the existing list. Let's say whatever. Close the bracket. And there you are. As I've been telling, you can type the code here itself on the terminal. Okay, but then when you type it here, you can execute it repeatedly. Once typed here, you may not be able to execute them in sequence. Nevertheless, let's see what is in L. Oh wow, L has so many numbers. Okay, so you cannot score it. There are plenty many. So what you do is, yeah. So sorry, bear with me. So I create a list L. What exactly did I do? I created a list L and then I populated the list with some 10,000 numbers, or maybe let's say 100 numbers, just so that it becomes easy. It doesn't scroll much. Okay, and it's easy to see, easy on the eyes rather. Right? Okay, say enter and you get 100 elements here from 1 to 1 million. Okay, so far so good. So then this is a big list, but I want a very big list. So what do? I start with L equals so much and then reverse L 10 million. From this I'm executing it. I'm expecting it to take some time, but it was really fast, very good. So if I say print of L, it will give me once executed. As I said, the variables will be there. You can execute and now you see L here. Okay, as you know, L of 0 will be the first element, L of 1 will be the second element. How do you see the last element? Len of L minus 1. Okay, so it does get stuck like this. This is very common whenever you handle a big list and your memory is full, and even your Python compiler requires some memory, your internal memory, also called the RAM. So this is very usual. You should get used to it whenever you handle a huge data. Okay, so the last number is 7891012, and that's precisely what you see here. Okay, I would like to check if there is a number. Let's say I'll type that here. Okay. Okay, so please don't mind the lag here because I'm generating big numbers. It can cry like this at times. Okay. Okay, so what's happening here is I had scrolled up and scrolled down, and it's happening slowly, whatever I did. Okay, so what I do is I say element, let's say A equals 567172. Okay, and I would like to check whether this is there in L or not. So how do I go about it? For I in range, length of L, which means I runs from 0 to up to the length of L minus 1, the whole of the array. Okay, if A is equal to L of I, print hep hooray, element found. Otherwise, you should print element not found. So as I've been saying, what you will do here is you will keep a flag variable. That's the most complicated thing in programming, So as we have discussed already, I'll not go in detail about this. You already know what this does. It will be sort of self-explanatory. So once you find the element, you break from the for loop, right? And then if flag is equal to 0, then you say element not found. Okay, so what's happening here? I think, a good way to illustrate this is to actually not use the for loop. Let's say I'll comment this. Please get used to commenting, right? So I'll type in a small array here, a small list here. Okay, 1 7 42 89 6 5 6 7 1 7 2 64 883. Okay, your element is definitely here, right? So what happens now when you say A equals 5 6 7 1 7 2? I'll just remove this for loop just so that. So what I'm not trying to confuse you people. All I'm trying to do is I'm trying to keep the list smaller. Okay, once you make it bigger, it doesn't matter. The program still runs, but it'll be easy on your minds if I keep the list smaller. I realized it as I was programming, so I'm doing it right now. Let it not confuse you. The programming is pretty simple and straightforward. All I'm doing is I initialize flag with 0 and I say I declare a variable A to be the number and check whether this number is present in the list or not. Okay, so I run I through the entire L. And in case this value A is equal to any value in L, I print hip hip hooray, I create flag equals 1, and then I break, which means flag is no more 0, right? Which means this will not get executed in case you have seen the element, right? This will only get executed if flag never became 1. So if flag equals 0, then it says print element not found. These programs might appear a little complicated to you to begin with, but with time you will get used to it. I just executed, it says hip hip hooray, element found. Just in case I were to type in some other element, let's say 567 is not here in this list, right? It should say element not found, it indeed says element not found. Now what we will do is I will include the for loop. You probably are wondering, sir, what is the big deal in seeing whether 567 is there in this list or not? It's obviously not there. It's visible for my naked eye. Why do you write a program for it, right? So that is when the complexity question pitches in. What if this list is not as simple as it appears here? Let me remove it. Okay, let A be 567 only, and I'm appending several. How much is this? As I was telling you, some 10 million, from 1 to 10 million, I'm appending a random number a million times. A random number as big as, let's say, 10 million, 1 to 10 million. A million times I append. Just stare at this for loop for a minute. Okay, and in that L I'm going to search, right? For 567, if it's there or not. Okay, I'm executing it, boom, L is not defined. That's because I made an error here of not initializing L. So simply I'm appending to the list L. The list L should exist. Unless it exists, I cannot append it. As simple as that. This kind of mistakes even you'll be doing. We are not going to edit these mistakes because these mistakes do happen. You must feel confident that everyone makes mistakes, and such mistakes when you make, you know how to fix it. Okay, so I run this and I get hip hip hooray element found, which means A equals 567, this particular list generated. Okay, this particular for loop, random number when I was adding, 567 got added. So let me execute it once more. Now element not found. 567 did not get included in this list. Alright, so you were wondering, why would we want to write a program like this? You're generating random numbers and you're finding a number there. Will this be the beginning of the world or the end of the world? Why are we even writing a program like this? I'm trying to tell you that you can do certain things really fast. Okay, many of the mundane things that we do in our life can be done really fast if we can write a piece of code. Of course, we stumble, we struggle in writing a simple piece of code like this, but then that's how programming is. But at the end of the day, you automate things, you see, execute it, and a big list gets created and it says element not found, right? Okay, so now let me modify this slightly and then try to ask you to type in for an element. It will check whether the element is present or not. So what should I do? I have a list L. Now list L is generated. It's a big list. Now what I'll do is I will print enter a number. Okay, and after that I'll take the number that you enter. Okay, input. As you all know, this should be integer. Okay, and then I'll initialize flag equals 0 and check if n is present or not. Okay, so instead of a, I'll put n. In fact, I could have called it a itself there, but never mind. So I have all these things. Perfect. Print enter a number. All right. So let's go ahead and then do this. But then what I want this to be repeatedly called. What do I mean by that? Enter a number. Type -1 to exit. What do I mean by that? I'll tell you. So what happens here is I'll say while n is greater than -1. Okay, then do this. Okay, so anyway, let me use. Okay, so perfect. So I'll just go ahead and then execute it. It says enter a number, type -1 to exit. I say 78. It is element not found, element not found, element not found. It's not stopping. That's because I made an error here. I made a mistake here. Let me stop this. I want this to be interactive. Okay, I'll put this inside. What do I mean by that? You will get to know this enter a number, type -1 to exit should keep happening, right? Okay, so I'll initialize n to be, let's say, 0. Okay, n is 0. I need to initialize n. That's why it's throwing an error here. N is 0. Please don't worry about my editor throwing errors. You know, that's how we all code, right? That is when logic converges, right? This is how you should get comfortable coding. So n equals 0, initialized, and then while n is greater than -1, definitely yes, n is greater than -1 because n is 0. It enters here. It says enter a number, type -1 to exit. I execute. It says enter a number, type -1 to exit. I say 19876. It says element not found. Enter a number, type -1 to exit. Take some random number, just element not found. I can keep doing this, keep doing this, keep doing this. In fact, none of these elements that I'm trying to find is present. So I'll type -1 and I'll come outside. Okay, so a good illustration is actually to type a list of your choice. Maybe you can type a list of all our date of births. Maybe there are 2001 borns here, I'm sure. There'll be some 1990 borns here, 1981, 1980 isn't here in the list, right? So using the for loop, I created a big list just so that you realize even it's like finding a needle in a big haystack, but still your program goes ahead and then finds it. Some of you are wondering, why am I writing such a complicated program? Some of you are wondering, why are we talking so trivial things, right? So please be patient. As always, I've been telling this, we are going to make things complicated for you slowly. So this week's discussion, as I've been telling, is about a few pieces of code. I mean, some 8 to 10 codes, the programs that we'll be revisiting again and again. There's a reason why I'm introducing this searching for an element in a list, as boring as it can get, but it will get very interesting. In fact, we will try to see how you can find a small word in your browser. You always type this Control F, right? How exactly does that work? You basically are starting with chapter 1 of that search, right? So what's the moral here and what's the bottom line here? Bottom line is that no matter how big the list is, we can search for an element there. In a very seemingly big list, very, very big list, with around 1 million entries, you can go ahead and search through the entire thing and stop when you find the element, right? So you may want to retype this code many times and then...
ये भी हो गया भाई, ठीक है। और अब आगे क्या करना है? अभी हम करेंगे ये द ऑब्वियस सोल्ट। ये हमने कर लिया, बर्थडे पैराडॉक्स हो गया हमारा, वार्म अप विद लिस्ट हो गया हमारा। अब ऑब्वियस सॉर्ट करेंगे, फिर डॉट प्रोडक्ट करेंगे। ये थोड़ा अच्छा था, मतलब नॉर्मल था एक्चुअली। आई वुड से नॉर्मल। फाइल के अंदर फॉर लूप लगाया हुआ है, फिर इफ का यूज किया है, नॉर्मल है। ऑब्वियस सॉल्ट।
Here you see is a list with some 8 elements, and I don't like this list because it's not sorted, and I'd like to go ahead and sort it. One way to do it, of course, is simply say L sort and then print L. Perfect. You see that the list is sorted, and the entire course is less to do with you using built-in functions and more to do with you understanding how you can write a piece of code all by yourself. So what I'll do is, let's say no to this. Okay, let's say no to built-in functions, and let's do it the hard way. I'm sure many of you are already realizing that I'm being a big fan of writing long codes, while we can actually do it with a very, very short snippet of code, right? So I'm doing it purposefully just to ensure that we get our hands wet and do it from first principles. Okay, so what's the fun in simply saying that everything exists? You see, the whole course, the whole of your BSc in data sciences and programming will be a waste because you needn't have to write a single piece of code, because everything that you will write probably is already there. Right? For practice sake, I think we should try to sort of reinvent the wheels. So let's reinvent this wheel of sort. Let us try to emulate sort. Let us try to redo how one can sort these numbers. Okay, so let me remove all the other things except for the list L. How would I sort this the obvious way? You know, in computer science, the moment you say sort, there are some dozens of ways in which you can sort a bunch of numbers. Let's do it the commonsensical way. And what's that commonsensical way? Let me try to reinvent my own sorting technique. Okay, so I will call a new array x. And what I'll do is for a moment,
खुद करते हैं यार, खुद करना, ठीक है। एक एक एलिमेंट को कॉल करते हैं, ठीक है। फिर अपेंड करेंगे लिस्ट को। बट कैसे? ये अपेंड करेंगे तो उसके आगे जुड़ता जाता है ना। तो अगर पहले मैंने 12 ऐड कर दिया, फिर मैंने 10 ऐड करना है, तो 12 के बाद में थोड़ी ना ऐड करना है, वो तो 12 से पहले का ऐड करना है। या फिर ये काम और कर सकते हैं, मैं पहले 12 उठाया मैंने, फिर मैं 12 को देखूंगा कि क्या ये सबसे छोटा नंबर है, तो फिर वो कहेगा नहीं ये तो नहीं है। फिर मैं कहूँगा ठीक है, जो सबसे छोटा नंबर है वो लेकर के आओ। फिर 12 से छोटा 10 है, फिर मैं 10 से छोटा पूछूंगा 10 से छोटा क्या है, फिर वो कहेगा 7 है, फिर मैं 7 से छोटा पूछूंगा क्या है, फिर वो कहेगा 6 है। तो ऐसे करके मैं सबसे छोटा नंबर ले आऊंगा, ठीक है। फिर मैं कहूँगा चलो जी 6 तो आ गया है, 6 को ऊपर वाली लिस्ट से हटा दो, बाकी नंबर पे वापस से बात करते हैं। पर ये थोड़ा थोड़ा मतलब लेंदी हो जाएगा ये, ठीक है। टाइम कॉम्प्लेक्सिटी इसकी बहुत ज़्यादा आएगी।
will not do programming, I'll use this place as a slate. Okay, so I will try to see through L and try to see what is the least element here. Okay, in fact, the moment you see it, you see 6 is the least element. But machine-wise, how will you find out what is the least element? What if this list were to be a very big list?
अगर उसी वैल्यू से कर रहा है तो पहले मैं करना चाहूँगा, ठीक है। करते हैं हम पहले, तो सेम यही कंसेप्ट लगाएंगे जो यहाँ पे लगाया हमने। ये वाला, ठीक है। ये हुआ लिस्ट, लिस्ट के अंदर लिख देते हैं कुछ पेपर के लिए, ये सेम ही लिखेंगे। 12 10 7 18, 12 10 7 18, 6 42 8 35, 6 42 8 35, ठीक है। तो ये हमारी लिस्ट 3, इसका कोई यूज नहीं है, हटा दो इसको। फ्लैग को एक बार के लिए पता नहीं यूज आएगा नहीं आएगा, नहीं पता अभी। फॉर आई इन रेंज, ठीक है, ओके। इफ लिस्ट आई इन दिस, ये तो हमें देखना ही नहीं। अब तो हमें ये देखना है कि जो आई हमने चूज किया है वो आई से छोटा, मतलब कोई भी अदर वैल्यू है या नहीं है उसी लिस्ट के अंदर, ठीक है। तो इसको कैसे करेंगे? हाँ, ये थोड़ा ट्रिकी है, थोड़ा सा ज्यादा नहीं, थोड़ा सा। तो करेंगे कैसे इसको? सोचो सोचो सोचो। सबसे पहले इसने 12 को उठाया, ठीक है। 12 आया, मतलब 0 को उठाया, 0 को उठाया, और फिर यहाँ पे आ गया 12। इफ 12, 12 तो आ गया। कैसे करेंगे यार, छोड़ो, दिमाग नहीं चल रहा।
and that just by staring at it you could
नहीं पता चल रहा अभी के लिए। साउंड आवाज नहीं आ रही ना? 2 मिनट।
sequentially from left to right. 18 is not less, so 7 is the least seen so far, but then you have 6, so then you remove 7 and say 6 is the least seen so far, and then 42, still 6 is the least seen so far, 8, 35, 6 is the least seen so far. The moment you do that, you put 6 here, and then remove 6 from here, and then repeat this process. I mean, this appears very complicated when we try to do it this way, but all I'm saying is pick the least element, put that to x, and remove that least element there. As you can see, you go through it, the least was 12, and then you saw 10, and the least became 10. Initially it was 12, and then it becomes 10, 10, and then it becomes 7, and 18 is not less, 42 is not less than 7, 8 is not less than 7, 35 is not less. I'm getting a solid, so we just 5, and then, so let's do that. You should find the least any list. If L of I is less than minimum, okay, just in case L of I is less than minimum, alright, only then you call minimum as that L of I. Obviously, here, as you enter the for loop, the first one will be L of 0 is less than minimum, obviously not, because minimum is already L of 0. 12 is not less than 12, so this will not happen. But then 10 is less than 12, so minimum will be equal to 10, and then 7 is less than 10, so minimum will be equal to 7, so on and so forth.
ओके, तो हम उसी से घबरा रहे थे यार, मतलब 12 को 12 से फिर कैसे करेंगे, ठीक है, बस, लेकिन इसने यहाँ पे बस माइनस वाला सॉरी लेस देन वाला लगा दिया, सॉर्टेड, इतना सा दिमाग नहीं चला यार, नींद आ रही है.
And finally 6 will get stuck here as minimum, and finally if I say print min, okay, let's see what happens at this level. Let me just stop coding and execute this and see what I expect here. I expect what to get printed here. I expect 6 to get printed here. Let's see if that's happening. Yeah, that's indeed happening here. As you can see, just now executed, I get 6 here. Just increasing the font size so that it's clear to you people. So I get 6 here. Very good. So assuming I plugged in some 5 here and then execute it, I should get 5. Yeah, I'm getting 5. This is how you code line by line, trying to ensure that what you're doing is right. Okay. So, but this is just giving me the minimum most number. I want the entire list sorted. How do I do that? So what I do is I don't print minimum. I plug in minimum to my new list X. Okay, and then I should remove that element from L. You see, we did some warming up of lists. Okay, in the very first lesson in this week, we did talk about how you can remove an element from a list. You simply say L remove min, and it will remove the first occurrence of that number. Don't break your head. You will see what's happening now. So let us print L, and let us also print. Let's also print X here. See what happens. So L becomes 12, 10, 7, 18, 6. 6 is retained. That's because we included 5. So 5 gets removed, 5 did get removed, and 5 has come here. Very good news. We are through. But then we need to keep doing this. So this entire stuff should be inside a small loop. You see, what is that loop? Figure out. So I'll say while L is not empty. L is not empty. Of course, we are not going to write it like that. We're going to write it symbolically. We'll say while length of L is greater than 0, which means length of L should at least be 1, which means L should have at least one element. Then I go ahead and do this, as I know slowly the length of L is decreasing because of this line here, where I'm removing one element at a time. Correct? And finally, outside this while loop, I'm going to display L and X. I'm hoping now that this will take care of the fact that my list X will be the sorted version of L. Why? Because I'm going through this entire thing again and again and again, trying to append new elements into X and the values of L. As one edition. This and then you see editor with some.
बहुत गंदा क्वेश्चन था, मतलब ठीक था, बट होना चाहिए था. आज के लिए इतना ही करते हैं यार, नींद आ रही है. ठीक है, थोड़ा कल रात को कम सोया था. चलो, इतना ही करते हैं आज के लिए. थैंक्स फॉर ज्वाइनिंग एंड आई विल सी यू इन द नेक्स्ट वन. चलो, जय सिया राम.